Thank you all for coming. Very much appreciated. This is Security in Cloudnative. So on the screen right now, in the top corner, you'll see a big red box with some writing in it. There's a URL in there. It'd be really helpful for me, and hopefully for you too, if we go to that URL. Promise nothing bad will happen. You're not going to get pwned, rickrolled, or abused in any way. But I think it should be obvious what that's about, and it'll be more obvious in a bit. So if you could go to that URL, that would be really helpful. So I was talking to my wife about this talk the other day, and she was asking who else was on the other tracks at the same time as me. And I said, well, John Skeet's on, and he's in that room over there, I believe. And she said, well, I'd go and see John Skeet. And I was a bit taken aback by this. She's not even a developer, she's an accountant. So I'm very grateful for you guys for sharing that. Thank you very much. I've had a lot of fun making this talk. I've had a lot of fun with the pictures as well. So this is a slightly tenuous cloud security picture, and they don't get any better, but hopefully you'll enjoy them. So yeah, if you managed to go to that URL, that's awesome. robinminto.com/poll. Right. So I'm Robin Minto. I work for a company called Buybox. We're a supply chain management technology company in the UK, operating globally. You won't have heard of us, but we've got lots of customers who you might have heard of. I won't mention them. I'm a technical architect, a software developer. We build web, mobile, and server-side apps, APIs, that sort of thing. We've got a distributed team of software developers in the UK. So why am I talking about security? Well, my interest in security goes back quite a long way. Now, this isn't one of the earliest computers that I had, but it's one of the earliest ones. You probably don't recognise this. This was created by the BBC in the UK, the British Broadcasting Corporation. This is called the BBC Micro. This was a 1980s computer that went alongside a television programme which was supposed to educate everyone about computers. And this was the computer they actually built, or had built, to go along with this TV programme. And in our school, we had a whole lab of these computers, these BBC Micros, on a network, pretty advanced stuff. And a good friend of mine and I used to pair program, and at that time, pair programming meant one of you would get a magazine with some code in, and the other one would type it in. That was pair programming for us in the 1980s. And we used to get code from magazines and from all over the place, and we built apps with some of that code that we found and put together. And we built this app which basically took over the entirety of the BBC network in our school, irrespective of what was happening. Put a graphic on the screen, played a sound, and the teacher just stood at the front, not really understanding what was going on. So I've had an interest in security ever since then. I went into app development. My friend at the time went to work on the Oracle security team, then went on to Google. He's now CISO, Chief Information Security Officer at Snapchat. I went the other way, so not into security directly, but into application development. But I've always had this massive interest in security. So that's why I'm talking to you today about it. So here's where that URL comes in handy. So if you all went over to that URL, you should have got a page saying that we're waiting for the presenter to start the poll. And I need to go to a URL, which is this one. Put that on the screen. Okay, so if I press this button here. So it'd be really interesting for me, and hopefully for you guys, to understand what you do, a bit about you. So as you can see, got a little mix of people. I'm guessing that top answer is developer. Could be the second one. Oh. So if I press this next. Okay, mix of architects and developers, cool. But we've also got some Other people in the room too? That's great. Who was other? What was other? No. Tell me later. Next question. This one's probably a bit more interesting. Again, a real mix. Okay. Okay, so I hope I'm not going to disappoint the cloud natives in the room, but hopefully there's something for everybody. I mean, obviously we've got a real broad mix of people in the room, so that's great. But we can do that. Okay, I will come back to that poll later. So why do we care about security? Well, people, I mean, for me, the key, people are entrusting their data to us. We've got a duty of care to look after it. That's for me, that's the primary reason. We don't want to see headlines like this. This is a headline from Motherboard about VTech, a large manufacturer of kids products. And they produced this little computer product which took pictures and had information on kids' information, and they stored it in a database which was publicly accessible. Someone found some of that data. They were quite lucky that data didn't get spread all over the internet, but somebody found that data, 4.8 million records, and thankfully it got contained. But we really don't want to see headlines like this. Is anyone familiar with this website? So, this is Have I Been Pwned by Troy Hunt. Troy Hunt's around about the conference. He's certainly did a talk yesterday, which I couldn't get to because I was on a plane. I got an email from this website just this afternoon telling me that my email address is in a breach. This is, this website is a breach aggregator. Really interesting site. But we don't want to end up on this site either. We don't want to be on this list. And that list kind of keeps growing all the time. Everyone familiar with this, or anyone not familiar with this? GDPR? So, I mean, Norway's in the EEA, not in the EU, but I think this still applies to you guys. And there's lots of opportunities in Norway to deal with EU companies, countries, people, and this regulation is going to apply. Now, I mean, certainly in the UK, we've had data protection law for years, and many, many years, but GDPR kind of raises the stakes, and companies are definitely paying attention. So, you'll hear headlines about the massive fines, the 20 million euros, the 4% of annual global turnover, those sort of numbers. And I think that's getting people's attention. Certainly, board level in companies, it's getting a bit of attention. And it's a great opportunity for investment in security. So, we've got an opportunity to actually improve our game. But, I mean, it really does often come down to money. So, even if a company doesn't have the sense to look after this data because they've got an obligation to, then they should be looking after it, because there are these big fines of a possibility, and it affects share prices, that sort of thing. So how are we doing? What's the landscape like? Well, not great. This is Breach Level Index. It's a website which tracks breaches, how many records were lost or stolen since 2013. Now, when I first took this screenshot, it was almost 5 billion, which is a pretty large number, 41 records a second. Not great, but actually that's July 2016, and actually now we're almost approaching 10 billion. And the number is up to 57 records a second, so we're not actually doing any better either, which is a bit upsetting. So we need to get that improved. So also I need to talk about what Cloudnative is. So we face this problem all the time in computing. Naming is hard. People come up with a catchy title for something, and nobody really understands what it means. So I'll try and talk a little bit about what I think it means and what some other people who are fairly interesting think it means as well. I want to start by talking about one thing that it isn't for me, and that is lift and shift. So lift and shift is where you pick up your virtual machines, your apps that you're running on-premise in your own data center, and move them up into the cloud and run them kind of as is. And for me, that's not cloud native. I look at this and I think that's what the marketing department think when you tell them cloud native. Everyone's going to have their own view of exactly what cloud native is. It's going to mean lots of different things to lots of different people. And I'm like, what? So let's talk about the sensible people. This is a really great talk from NDC London, last year in fact. Another NDC speaker who's here, Ian Cooper. This was his talk on 12-factor apps. Definitely worth watching. 12-factor is a methodology that comes out of Heroku, the Heroku platform, and they recognize certain practices and patterns that were good for building cloud apps. And certainly when Ian was talking about this last year, we were thinking about cloud native in those sort of terms. More recently, actually, NDC London again, that's this year. Sam Newman talking about cloud native. What is this cloud native thing anyway? And he went into great detail, moving past the 12 factors, talks about definitions from the Cloud Native Computing Foundation, settling on this one from Pivotal. So this is quite a good definition, I think, for me. It talks about DevOps, combination of that with continuous delivery, containers, and microservices. And the microservices bit is helpful, but it's not essential. So it's a combination of those things. And Sam Newman also makes a really good point about functions as a service. So if you're running Lambda in AWS or Azure functions, then at that point you're still doing cloud native, but your containers are basically an implementation detail. So the platform kind of abstracts that away. You don't actually see that bit. I know Sam Newman also did a talk yesterday, which I missed again on a plane, on the security of microservices. So yeah, I'm a big fan of Sam Newman's work. So, cloud native, your apps and services, they're born in the cloud, and they use a certain set of technologies to make it happen. So DevOps, continuous delivery, containers, and possibly microservices. So you might notice at the bottom, the URL, this comes out of a company called Pivotal, and I'll just touch briefly on those guys. So Pivotal was spun out of EMC and VMware. It's a company that they're intended just to market some of the products that they own the IP for. So you might not know the name, but you might know some of the products. So you probably know RabbitMQ or Spring. But they talk about cloud native and cloud native security because of their Cloud Foundry product. So Cloud Foundry is a cloud platform for private cloud, but you can run it in public cloud as well. And they're building security into that product, and they talk about how they do in that. In this talk that they've been giving for a while, they're talking about cloud native security, and the 3 R's: rotate, repair, repave. And I'll go into those in a bit more detail, but I just want to talk a bit first about one of the other things that they call out, which are the threats that face our applications. So their suggestion, and I do agree, is that there are 3 major threats facing our application, and the 3 R's help deal with these threats. So I'm going to focus on the 3 R's, and I'm also going to focus on these threats. So the first of the 3 R's is repair. This talks about fixing our software, patching our infrastructure. We take advantage of our continuous delivery pipeline and processes to ship fixes quickly, all of our software components. So we can deploy fixes quickly. So that's good from a development perspective. We can ship features to our customers, but it's also good from a security perspective, because if something's vulnerable and we can fix it quickly, then it's no longer vulnerable. Second R is repave. So here they're talking about rebuilding virtual machines and containers from a known good to a known good state. So you destroy it and you start again. And that change is hostile to malware and attackers. So if you destroy and recreate your operating system or your container, anything lurking in that operating system is destroyed. So malware doesn't have a chance to act, or it doesn't have a chance to spread, and any bad actors in your system don't get a chance to move around and exploit a foothold in your system. And then the last of the 3 is rotate. So this is talking about credentials, certificates, and keys. So rotating them so that if they're compromised, they become useless to an attacker. And you do it often, and they're useless more quickly. So the 3 R's are particularly relevant to Pivotal and Cloud Foundry, but there are other cloud platforms out there. I'm sure a lot of us are using these, maybe Google as well. These are some of the bigger ones. I suspect most people are using these. I'll test that in a second. So I want to talk a bit more generally about Cloudnative. I've talked about the Pivotal approach, but for me, it's not just about Cloud Foundry. So if I go back to that poll, be interesting to know what cloud providers people are using. Certainly some people doing cloud development. There's a big winner there. Okay, so look. Okay, Azure's the winner. I'm surprised. I did actually think Amazon Web Services was going to come out on top. Really interesting. Yeah, a bit of Google, a bit of other. Yeah, so I think, okay, that's really interesting. Thank you for that. That's helpful. For me, as I say, it's not just about Pivotal, but they've got some really interesting things to say. So if we are building on this cloud infrastructure, we're putting our containers out there. We really need to make sure that we're putting our containers on trustworthy infrastructure. We don't want to deploy our containers and have the infrastructure fail. You need to be able to trust your infrastructure. You need to make the right infrastructure decision, and I think that that's probably why lots of people are going with Azure and Microsoft and Amazon and Google and the like. So, on-premise is great. We've built some containers on-premise, and you can run lots of different loads on your container infrastructure, and that's great. But for me, this is what we're talking about when we talk about those tier 1 providers. They take it to a completely new level. They've probably got a much better security team than you do. I suspect they probably literally do have guns in some of the US data centers, certainly razor wire everywhere. Microsoft have got 3,500 security professionals working across the company. That's a number that I can't even think about competing with in terms of security expertise. So I think what I'm saying here is that we can trust the infrastructure security. And cloud providers have also got the potential to analyze millions of data points. So they can look at the entire cloud infrastructure, and they can see all of the activity that's going on, all of the attacks that are happening, not just your bit of it, but the whole thing. And they can see and connect the dots to lots of security problems really quickly. This is something that we just can't do. And Microsoft are providing access to alerts through their Graph API. So if I were to go over to Microsoft Graph Explorer, this is just an example, but you can come in here and just run a query. You get some results back. If I zoom in, they're saying that a user logged in from a new, unfamiliar location based on user's past login history. This is the sort of quality information that they can provide that you just can't do outside of the cloud. But it's not to say that there won't be issues in the cloud. So I don't know if everyone's familiar with the Meltdown issue that happened fairly recently. So Meltdown melts security boundaries normally enforced by the hardware. It allows escape from virtual machines. So that's a problem if you're if your virtual machine is sharing a host on a shared infrastructure, on a shared cloud infrastructure, public cloud, I should say. So, but if we're architecting for cloud and continuous delivery and containers, the result is that the infrastructure provider, the cloud provider, patches basically just moves your workload onto a different machine. We saw this very thing with the Meltdown vulnerability. Certainly Azure were very fast to patch, and they just move your workload to a different machine that had been patched. And it's the architecture of the cloud that allows us to do that. Amazon have got a really interesting statement on shared responsibility, and they call it the shared responsibility model. It's worth having a quick look at that. So they talk about the distinction between the security of the cloud and the security in the cloud. So security of the cloud is their responsibility. They're responsible for the hardware and all of the infrastructure, some of the networking software, the database components, availability, that sort of thing. And then as a customer, we're responsible for security in the cloud. So that's the data, the platform, the applications, access control, operating system, firewall config, that sort of thing. For me, actually, operating systems are kind of less of a concern with the cloud native, because we're talking about containers and functions as a service. So that is kind of less of an issue for us, but all still relevant. Now, the thing about this is that they give us a lot of power. They give us an awful lot of configuration options, but that's an awful lot of configuration options that we can get wrong. So a big part of our responsibility is to make sure that we configure everything properly. And there are some interesting things around to help us deal with these kind of problems. So there are 2,500 plus permissions in AWS Identity and Access Management. So you can look at the AWS Access Advisor, and based on what your application is doing, you can tweak those permissions so that you're using the principle of least privilege. You're only granting the privileges that your application needs. But that takes a bit of effort. You can't just go in and switch everything on because it's really easy. You need to actually think about what you're doing. These graphics relate to a couple of things that Netflix have released that kind of automate some of this stuff for you. So depending on your scale, this may or may not be useful, but Aardvark, which is the thing on the left, is actually an app which uses Phantom.js to scrape the AWS Access Advisor, takes all the information and stores it into a database, which they put a REST API on top of. And then RepoKid, which is the other one, is an app which uses that data. It repossesses unused permissions based on the data that it gets from the Aardvark database. So, that's automating this to the next level. So that might be something that's useful. Now, the cloud providers give us firewalling capabilities at a again, at a next level. So, on-prem, in our own data centers, we might have infrastructure in different security zones. You might have web servers in a DMZ, but the cloud can take it to a different level. So Amazon has security groups where you can you have different instances in a group, and you effectively have a virtual firewall for those instances, so you can control traffic in and out of them. So it's much more granular. It's software defined, so you can control it via API. Just much more flexible. And then you've got another level again, which is the network access control lists, which means that you can control access between subnets. Again, you've just got much more flexibility. So just going back to those three threats that I've been talking about. As I say, I'm going to talk about how they're sort of generally applicable. So, Pivotal raised these as things that they wanted to deal with in their way. I'm going to sort of take a slightly different route. But I guess the key of all the stuff that I've just been talking about is that trusting our infrastructure means that we can concentrate on other threats. And the first threat that we start with is the vulnerable software. And we sort of go back to basics with some of this. So there are lots of similarities with non-cloud native apps. And OWASP is still valuable. I don't know, is there anyone who isn't familiar with OWASP? Okay, so one or two. So OWASP is a charity. It's a set of user groups around the world. They create projects and articles and documentation around web application and mobile application security. So it's the Open Web Application Security Project. And they produce some security standards as well. But they create lots of interesting tools and projects that are really useful for web application security. Checklists for security development life cycles, all sorts of different things. But one of their flagship projects is a thing called the OWASP Top 10. It's the 10 most prevalent, risky, they categorize them in different ways, but kind of 10 vulnerabilities that we should start with, that every app you should start looking at. I mean, it's just a starting point, but it's a great place to start. And at number one for years has been injection, and it's still number one. An injection, it talks about your traditional SQL injection, but it also talks about NoSQL injection, LDAP, and there's various other forms of injection. And so this needs to be something that we're thinking about, even with cloud native. We really do need to pay attention to the basics. I mean, one of the things in our favour is that if we're doing cloud native, we're probably using a modern framework which is going to protect us against a lot of these threats if we use them properly. But really, it's about just understanding that these threats are out there, and we need to cover them. I mean, passwords. 81% of hacking-related breaches leverage stolen or weak passwords. So it's great having a great new shiny cloud-native app, but if you're not handling passwords properly, it's not going to help you. So, protecting your passwords in the way that you store them, if you're storing them at all, blacklisting the passwords that are just bad. Everyone knows. I mean, there's a good example of a bad password. You shouldn't be letting your users use passwords like that. There are some great services great lists that you can use to blacklist passwords. In fact, Troy Hunt, who I mentioned earlier, has got a great service to allow you to look up all of the passwords that he's seen in data breaches and blacklist them. And things like throttling authentication attempts with captures or however you want to do it, just to stop people from brute forcing your system. Or you might just, if you're in the cloud, you might just use a third-party authentication provider to help, so you don't have to deal with this sort of thing. But we've got to cover the basics. And then, we're now using containers, and we have to think about how we deal with those as well. So, if you're using containers, you might be just taking a container from a repository and using it without understanding really what's in it. Or you might want to deal with threats to your containers within your own company, but you can use static analysis to scan for issues. This kind of goes back to the repair aspect of the 3 Rs and repairing the vulnerable software. Scanning with static analysis would allow you to detect issues in your containers early. And there are various tools out there to help us with this as well. So there's Claire, which is a product it's an open source product, open source scanner from CoreOS, and they've built it into their key container registry. So it scans, if you use their container registry, it automatically scans them for vulnerabilities. And then you can buy commercial products like Twistlock, which they position themselves as a container security platform, but it's a similar sort of thing. So this graphic, I searched for supply chain and this came up, and I thought it was funny, so I left it in. But this is somebody went to the effort of putting that image together. I don't understand it, but I hope you remember it anyway. So supply chain issues are the sort of issues that were sort of touched on a bit with Docker containers, but it affects more than just containers. Anytime you're bringing in software from a third party, you've got a risk of a supply chain issue. There was an incident recently with a JavaScript library. It affected a lot of companies in the UK and actually worldwide as well. In fact, the Information Commissioner's Office, which is the regulator in the UK which is responsible for data protection, their website had this problem. It's slightly ironic given all the GDPR stuff. So the problem that happened onto their website was that they were including an accessibility JavaScript library from a third-party website. And this affected all sorts of government organisations all over the place because they were all very interested in accessibility, and they'd included this component, which was a very good component, but that component got compromised, their website got hacked, and somebody changed the JavaScript file to include cryptocurrency mining code. So all of those websites, and there were 4,000 plus of them, if you then went to their website, suddenly your browser's doing cryptocurrency mining on behalf of this person. And so these threats are on the increase. The criminals are finding that turning electricity into cryptocurrency is a great way of making money for them. Really wasteful, but they don't have to pay for the electricity, so they don't mind. So these kind of threats are on the increase. So we're looking at scanning containers, scanning NuGet packages, NPM packages, whatever our package manager of choice is. And then there are techniques like sub-resource integrity and content security policy that we can use to help with including JavaScript libraries from third parties. So these are the sort of things that we need to look at for those to prevent these supply chain issues. So that next threat that Pivotal mentioned is leaked credentials. I actually think it's better to think about leaked secrets because it's a bit broader. I think credentials is a bit too narrow. And here's a good example. This was Uber. Uber had a bit of a breach. They tried to cover it up, and they didn't do very well. It meant that more people found out about it, I think. But one of their problems, one of their several problems, was that they put security credentials into their GitHub repository. Now, maybe when they did that, they thought, okay, well, this is private, nobody can see it, but even if it's private now, it doesn't necessarily mean it's going to be private in the future. So, don't put these kind of secrets into source control, or if you do, encrypt them. But just assume that it's going to be public at some point. And there are tools out there to help us with this as well. So this is the continuous delivery tools plugin for Visual Studio, and this will automatically detect Azure secrets, things in connection strings, Active Directory credentials, that sort of thing. SQL, Cosmos DB, all sorts of different credentials, and it will pick them out of your source code for you. And Microsoft are actually using this tool in an automated way by monitoring GitHub commits, just to look for those kind of secrets. And they'll send you an email and tell you that you've done this. But you can catch it much earlier the earlier that you do that check, the better. But you can check. I wanted to talk a little bit about functions, because again, for the same reason, leaked credentials or secrets. So I'm not sure how many people are actually using functions, but we've done a little bit with them. One thing that I notice is that every function gets a code. It's a token that goes at the end of the URL, which is effectively the authentication for that function. You can have one per function. You might group them into a group of functions, but I can just show you that in the Azure portal. So I'll just go here. So here's my Azure portal with the functions URL in. So I get my functions URL, and basically there you can see the code. So that's a unique code for this function, but that is basically all that I need to authenticate for this function. So you could now take that URL, off the video, type it in, and use that function. But so they do provide tools to manage these. So I can go in, and I can revoke or renew those keys. But that's still a secret that we've got to manage somewhere. And if you're checking that into source control, if you're embedding that in an application, you might be spreading that secret inadvertently. So you might switch to Active Directory authentication. Instead, you might use some other third-party authentication. You might use Identity Server or something like that. But it's just something that's not immediately obvious. Now, the 12-factor methodology talks about how we're changing the way that we work with environment variables. So what you'll notice is that we're moving away from environment variables. We're moving away from config files to environment variables. So this is great for our cloud-native apps, but it introduces another issue for us, in that environment variables can leak. So there are lots of logging tools and management tools that will automatically look at the environment variables for a container or for a host, and they'll export them, and they may end up in some much more public place, somewhere you're not expecting. So it's making those things much more accessible. Now, it might be that we have to move away from host environment variables to something network-based, like something like console might help with this. But again, secrets that can leak. And there's even a new term, cloud leak. This is coined by a company called UpGuard. UpGuard provides software that monitors software environments. So this is exactly the sort of product that might leak your environment variables, because it will look at your config and your setup, and it monitors for security and policy issues. You can set it up to look for changes It's a really helpful product. They've got a great security team, and they do a lot of work looking at S3 buckets and leaky S3 buckets. And that's where the term cloud leak comes from. And they've done a lot of work on exposing basically public S3 buckets. So people have created an S3 bucket and they've made it public. And yeah, it becomes a bit of an issue. So they've gone to a lot of trouble to find some of these buckets and report them to the people who actually own the data before somebody else finds them. But it's so easy now to have a resource like an S3 bucket that just becomes publicly available. So easy. So in the olden days, you put a file on your file server, that wasn't going to accidentally leak out of the firewall, with the flick of a switch. That was going to be you phoned the sysadmin and you asked them to change the firewall, or you submitted a change request. It was just a lot more steps. Whereas now it's an option in a drop-down list, and they're making it pretty obvious in the UI. So this is in the Amazon UI. You pick the public access option in the list, and it does try and warn you, and they warn you elsewhere in the UI as well. So it looks like this. Here are those warnings. Obviously, that's pretty in your face, but there are tools again that can help us with this. If you wanted to try and find exposed buckets, there are tools that will go and do that for you. There's one called AWS Bucket Dump, and there's one called Buck Hacker. So you could use that on your own system, or you could use that on other people's. I didn't say that. Or there's a really useful auditing tool called Scout 2. It's an auditing tool for AWS environments. So you basically just run this Python script. So I can do that like this, and I just hit go, and that will go and examine my AWS configuration. It runs it against a certain set of rules, trying to find issues that it can, and it can warn you against these kind of open resource problems that might be a problem. That's going to take a while, so I'm actually going to quit that. Yeah. Nope, there we go, off it goes. But I've got one that I prepared earlier. So I don't have a huge number of resources in AWS, but I can see here if I go to EC2, I've got some ports open perhaps. There's a variety of different things, problems here. Lots of green, but a couple of red. And it's got all sorts of different options to look at. So that's a really powerful thing. And this is kind of reminiscent. This issue that I was about to talk about is reminiscent of the environment variables issue. But login secrets to your logging platform can also be a big issue. Now, you might be doing that inadvertently. You might be logging just to your container, but outside of that, your infrastructure is taking those logs and pushing them out to Kibana, or something similar. And if you're not thinking about what you're actually logging to your container, you end up logging secrets out somewhere much more accessible. And you think actually, well, I'm not going to be so silly as to do that. But some people have already done it. So GitHub did it recently. They had a bit of an issue where they accidentally logged passwords to an internal login system. And you think, well, blimey, maybe just a one-off. GitHub did it. Twitter did it as well. Like 3 days later, they came out and said, actually, yeah, we've done the same thing. So, yeah, it's something to watch out for. And the final threat that I wanted to talk about, time. So apps are fairly often just left. Once they're written, they get deployed, and maybe they get left. And they only get more and more insecure over time. So cloud-native practices give us the ability to continuously deploy, to update these things. And we should be using that capability. So, update. Make sure you're updating all of your things. Updating your code. Again, updating all of your dependencies. So your packages, your containers. Build continuous updating into your processes. So you've got all these techniques for cloud native. You can leverage them for updating all of your things as well. There's lots of different things that can help us with this. So OWASP have got the safe NuGet project that can help us with NuGet packages. Retire.js is a long-standing project. I do like the tagline: "What you require, you must also retire." You can monitor your dependencies for issues, checks your JavaScript libraries and your npm packages. But it's not just a JavaScript problem, of course. There's tools here. This is SNCC or Sneak, depending on your point of view. Short for "So Now You Know." It's a dependency scanner and also the vulnerability database. And that database is used by another product. So this is a paid product. This is a free product called SonarWall. This uses the SNCC vulnerability database. SonarWall was created by the Microsoft Edge team. And they quickly thought, well, actually, this is something that needs to be open sourced. So they did that. And that checks performance and accessibility as well as security things. But notably checks your JavaScript libraries against the SNCC vulnerability database. And SonarWall is basically a web app. So you go to their web app, and you put in your URL, and off it goes. Queues it up. Here's the results. I go to the security section. Got lots of various errors here that I could go into. SRI errors, SSL labs errors, etc., etc. Another great tool. And OWASP are also in this space as well. They've got a project called the Dependency Check Project. This is another paid product, but I really like the way that they handle some of the changes. So this is dependable. It works with JavaScript, Python, Elixir, PHP, Rust, Docker, various other things. The way that works is that it checks for updates in your GitHub. If it sees any issues, it then opens a pull request for you, which you can then review and merge manually, or you can do it automatically if your tests pass. And for me, that's an awesome approach. So, just to summarize, for me, cloud has many positive impacts on security, and cloud native adds on top of that, giving us continuous delivery, just the ability to roll out changes quickly is massively beneficial. Architecting for failure in the cloud, failure of hardware and network and software, which we need to do to be cloud native, means that we're in a great place for security as well. So these issues come along, security issues, and we're, because of our architecture, we're in a great place for those to be resolved. But we've still got many of the same application security issues. So we still need to cover the basics. We still need to deal with all of the things that we've done before, and we need to get better at that because we've shown how badly we're doing that already. But the frameworks are coming along and helping us a little bit with that. But then there are some new threats that we have to worry about as well. There are misconfigurations that we can make. There are so many different options for shooting ourselves in the foot. We need to be really conscious of that as well. But there are some amazing tools that we can use to help deal with some of these problems. So that is what I wanted to talk about. That's Cloudnative, security in Cloudnative. Hopefully that will make us a bit more secure. Hopefully there's some interesting things in there for everybody. There are some links to the resources that I've pointed to on my blog, robinminto.com/talks/cloudnative. I think I've got a little bit of time for questions, if anyone's got any. Good. I've answered all the questions. Fantastic. Well, thank you ever so much for coming.